Hello, everybody, and thank you for joining our webinar, Shifting Left on Cloud Infrastructure Availability. I think we are ready to get started, so let's get started. My name is Iris Zarecki, and I'm VP Marketing here at Continuity Software. And with me today is Avi Aharon, our VP Cloud. Hi, Avi.
Hi, Iris. Very happy to be here.
Great. And in today's webinar, we'll be talking about starting with the digital transformation and how it impacts business and technology, and then shifting gears and talking about shift left and how does it relate to preventing outages on your public cloud infrastructure. And we'll end the webinar by giving you some 5 practical examples of risks that threaten your public cloud resilience and that you can avoid with a proactive shift left approach. And as usual, we'll end the webinar with a Q&A session. So feel free to start submitting your questions using your webinar control panel already and throughout the webinar, and we'll address all the questions at the very end. So with that, let's get started. So Avi, everybody's talking about digital transformation, but how does it really impact business and technology?
That's a very good question, Iris. Frankly speaking, last week I've been in the AWS New York Summit, and Werner, Amazon CTO, spoke about this shift, and he mentioned that basically it's driven by business requirement, and definitely has a large effect on how companies develop, deploy, and test today. So a question raises who is basically taking their responsibility. And what we have seen regarding this shift is companies used to, in the past, to have a monolithic large application, usually managed by centralized IT group, and deployed either once or twice a year, and basically relying on their on-prem physical infrastructure. But in today's world, we start to see companies using more and more microservice technologies, containers and Kubernetes. The teams are also evolving. We do see how their DevOps team and small application groups, like a small startup within an organization of 20, 30, 40 people, and they take responsibility on what they do. And the bottom line, and this is again driven by the business, these groups are committing several times a day. So we are not talking about twice a year anymore, but several times a day. So it's definitely a major change. And they are relying on multi-cloud environment and being hybrid. So just to take that into the next step, this kind of shift, this kind of evolving, there are 3 major pillars that we do see out there. So it's a combination of complexity, ongoing changes, and knowledge gap. When I say complexity, again, it's a combination of the environment itself. Usually it's going to be a multi-cloud and hybrid environment, which make it challenging. Multi-layered, these companies are using either IaaS, PaaS, SaaS, managed, unmanaged services, and with multiple teams, like DevOps teams or application groups. They also have several kinds of vendors, if it's cloud providers, and such things. And on the other end, moving to microservice technologies and deploying several times a day, they need to make sure that after committing and adding new changes into their environment, they need to assure that they are still reliable and they didn't create any risk to the organization itself. And the last pillar, which is the knowledge, we do see that cloud providers are adding more and more new services and features. We are talking about thousands of new features annually, and they need to make sure that companies are able to train the teams and that this information is out there and updated on a daily basis. So basically, and definitely a new approach is required here.
Right. So let's expand and drill down a little bit into each one of those pillars. And the first one is complexity. So what we see here in this very interesting research from VMware is that while the number of workloads is growing exponentially, almost 80% of them will be running on a cloud-based infrastructure, with the public cloud leading the way and private cloud still there. In addition to that, in this research from RightScale, we see that enterprises are, 84% of them are applying a multi-cloud strategy, and on average, they have 5 clouds. They're using 5 clouds. So complexity is definitely growing. Let's talk about changes, ongoing changes, Avi.
Yeah, so we do see a paradigm shift also in the software development itself. Companies used to work, or development groups used to work on the agile methodology, moving to DevOps, and now CI/CD pipelines and automation. So there's a major shift over there. We do see how there's smaller development groups, like a small startup, as I've said initially, a very short development cycle, 2 weeks, 3 weeks, ongoing deployments on a daily basis, and a short delivery cycle, which is basically today's business need. What you see over here is research done by Forrester, and what we can see is that currently 10% of the organizations are deploying on a daily basis, 15% on a weekly basis, 40% on monthly basis, and 35% on a quarterly basis. So definitely it's a movement. It will take time, but the trend is to deploy on a daily basis. This is where companies are going to. So the third pillar, which I've mentioned, pace of innovation, and I've been in the reInvent 2018 Vegas, and Andy, Amazon CEO, spoke about the number of new services and features that AWS came out into the market in 2018, and it gets to more than 5 new services and features per day. This is a lot. So this is definitely becoming a major challenge within an organization. Are you capable to even read or understand or learn about this new pace of innovation, and then to make sure that you are aligned?
Interesting. So let's take a quick reality check and check how do these changes actually affect reliability. And I think we see that on one hand, more than half of the organizations actually believe that it's the cloud provider that is responsible for their uptime and availability. But the reality is not exactly that. Right, Avi?
Yeah. Again, last week I heard Werner saying that the developers are the quality owners. So the bottom line is, within the organization, it gets to the developer itself. But the relationship between the organization and the provider is quite challenging. They have this shared responsibility model, which eventually means that they don't take responsibility on those SLAs. They split the responsibility, depend on the service that you're consuming. If it's IaaS, if it's PaaS, if it's SaaS, eventually you have a part in taking the responsibility on yourself. So it's definitely a major challenge for those organizations from the perspective of availability and from the perspective of security.
Right. And when you look at the newspaper headlines, you see the same exact phenomenon. You see just some examples here. And we all remember the Twitter outage just last week in the middle of a White House social media summit. We still remember Salesforce that had a big outage in May, and Facebook before them in March. So outages do happen, and they happen on public cloud as well. So with that understanding, let's move on to the next second half of the webinar and talk now about shift left and how does it apply to becoming more proactive and avoiding outages on your public cloud infrastructure. So let's talk about shift left first of all. What is it? What does it really mean? So shift left is a practice, and it's intended to find and prevent defects early on in the software development process. The idea is to improve quality by moving tasks to the left as early as possible in the life cycle, as early as possible. And why? We can understand very well by looking at this chart here from IBM. It costs you 100 times more to solve a bug or a defect at the end of the life cycle versus solving it early on in the design phase. So definitely from a cost perspective, it makes much more sense to try and find and resolve the defects early on. But I think this is more than just a cost issue. It's really a shift in the mindset. It's a shift in the sense that everyone is taking responsibility of the quality of the software. It's not just a QA department anymore. It's every developer and every development team. Everyone is in charge of quality, of their own quality, and testing is done throughout the entire life cycle of a software development and as early as possible, as I mentioned before. But Avi, how do we apply that to cloud infrastructure resilience?
So you remember what Werner said? The developers are the quality owners, okay? So what does it mean? It means that you have to start testing as soon as you can, as soon as you even start deploying. You press on the commit button, and this is the developer. Then you need to make sure that before it gets to production, all the risks are out there, which might be over there, will be waived. So part of the CI/CD pipelines, which is this is the way that a company works. They need to make sure that they're having those sanity tests, those integration tests, performance tests, security tests, resiliency tests. This is part of the overall testing that they have to do before they commit into production. They need to make sure that they automate the process in order to be on the safe side. So I think that the conclusion for that is practically it's impossible doing that manually, and you must automate.
Right. So let's look at a couple of examples of risks that you can find and should find before going into productions. And in these first examples, we see 5 scaling groups using the same EBS volume. What's wrong with this example, Avi?
Okay, so what we see over here is a general purpose SSD volume, which has a limit of 307 gigabyte. And this specific case, customer has 4 scaling groups and some static instance that currently consume 291 gigabyte. But once they will scale up, they may require to consume around 488 gigabyte, which will eventually cause an application downtime as for the EBS limit. So this is a very simple example of a limit, which is almost any resource in AWS has a limit. So taking a proactive approach will mean that eventually after I will deploy something into the staging and later on to production, I will be able to recognize that there is a risk over here and will handle it before going to production.
Wow. Okay. Moving on to the next example, this one is about security. And security is always a concern when talking about public cloud. But what do we see here?
So what we see over here that in North Virginia region, there are 3 instances with a public IP address, and they have an unrestricted SSH access worldwide, which basically present a major security risk.
Wow. Moving on, what do we see here? A missing resource?
So yeah, so this example is around missing resource as part of a launch configuration. So a block device snapshot is missing, which means that eventually if the customer has defined an auto-scaling group, it will need to grow and add another instance, it will fail because of this missing snapshot, which will definitely create a major performance issue that may lead even to downtime.
Right. Let's move on to our next example. This is also about snapshot.
Yes. So what we see over here is that there is a Linux VM which has a partial point in time copy. We do see that the customer attached in February 2019 another disk, and but he forgot when he did the snapshot 1 month later to have the snapshot also the additional disk, which will eventually, in a cyber attack, might be in a situation that it will not be able to get back his data, and we are going to talk about a data loss over here.
Wow, scary. And our last example has to do with Azure. Let's explain this one in more detail.
Yes, so in this specific case, we do see a subnet here, which has a limit of 256 addresses. Currently, 238 addresses are being used. And the customer has 4 VM scale set groups that may require to grow with an additional 22 instances, which will require 22 addresses. But in that case, there aren't any sufficient number of addresses available. Again, may cause a downtime or a major performance issue.
Right. So we saw some scary examples, which are typical, and you see them with a lot of customers that we visit. What are some possible approaches to shift left reliability that you see customers taking today?
So we understand that we need to be proactive. The customer needs to be proactive when speaking about availability, and this is what shift left is all about. So I would say the traditional way and might be relevant in a very small environment is just having or doing a manual testing around availability. This is not so practical for even medium and definitely for a large organization. Then what we do see out there is companies are writing their own automation and scripts around testing. So it's not only automating the process, but also automating and maintaining those tests around availability, as they do around security and other pillars. But then you need to have the right people over there. They need to have the knowledge, and as we know, it's evolving on a daily basis. So it's also becoming a bit challenging. And the third approach is out-of-the-box tools that the cloud providers like AWS and Azure are providing. Again, these are very basic and limited tools. AWS has the Trusted Advisor. On the availability pillar has around 20 checks, which is definitely not so much and didn't change really in the last 5 years. And Azure as well has around five checks. But again, they provide capabilities on a region basis, account base, and on a specific provider, and by definition, they're quite limited. And the last approach is out-of-the-box third-party solutions that are focusing in providing a resilience assurance solution, being proactive, either on the staging or production environment. But these are third-party solutions.
Right, so we have a solution like that at Continuity Software. It's a product called AvailabilityGuard NXG. Will you be so kind, Avi, to show us a very quick demo of what the product actually looks like?
Sure.
Let me give you control.
Okay, great. So what you see over here is AvailabilityGuard NXG. This is our dashboard when a customer just log in to the platform. Initially, customers need to define on board the accounts that they would like that the solution will scan. Our solution is a SaaS offering deployed on AWS, but it can scan AWS accounts, Azure accounts, and other provider accounts we support. In this specific case, we do see that the customer onboard 2 AWS accounts and 2 Azure accounts. In total, the overall accounts include up to or around 350 nodes. It's very easy to define an account in the NXG solution. Over here, you can see that we can either define the authentication on a role-based authentication or key-based authentication. Of course, the best practice is to use roles in AWS. Once we onboard the accounts, the platform will start to collect the configuration data from the cloud environment. And very quickly, the customer will start to see and get indication from the solution about how healthy is the environment. And whenever we find a risk, you can just drill down and get more into deep information about the risk and recommendation how to resolve the misconfiguration. So what we do see here is that this specific customer has deployed on 4 different regions. So using AWS deployment in North Virginia and Ireland, and 2 more regions deployed on Azure. We do see that one of the region scoring is quite poor, and this is North Virginia. And we see that in this specific case, the customer has 4 critical high risks. So we can just drill down and get more information on that, and I'm going to do that in a second. But just to give you more information about what you can gain through this navigation pane is a capability to drill down either based on impact or business impact or a domain, whatever is in your interest. And so in this specific case, I will just pick up one of the risks. This risk is talking about limits. You remember that in one of the examples that we've described initially, we spoke about EBS limits. In this specific case, we are talking about EC2 instance limit. And what we see over here that the NXG detected that the customer is currently using a 16 EC2 instance from a specific instance type, and the limit is set to 20, but potentially it can grow or required to grow up to 36, which may cause a major downtime or a major performance issue. So, so NXG will recommend to increase the limit in order to meet this requirement. Iris?
Yeah, thank you. Yeah, thank you. This was very informative, and you really did it very, very quickly. So thank you for that. So just to summarize, Avi, what kind of use cases do you see of becoming proactive and shift-lefting your resilience?
Yes, I think these are the main use cases that we do see out there. So it starts with integrating into the customer's CI/CD pipeline. So being proactive means that you need to take an action before you go to production. We remember the responsibility is in the end of the developer. So we want to make sure that once getting to production, everything is cleared. So being able to detect those risks around availability before going to production, waive them or handle the potential misconfiguration, and then commit to production. So this is a very important initial proactive approach you can take before going to production. And second is once you are on production, still changes can go there, even if you're not using a staging environment. So you need to validate on an ongoing basis that your production environment is clear and you don't have a potential hidden risks over there before they impact business. Security and cyber resiliency and availability are going together these days. So you need to ensure also that the configuration that you have is totally secured, so you're not exposing yourself to cyber attacks. And part of improving your operational costs, I think that the ability to detect those risks, to come out with recommendation, but also to provide the code in order to remediate the specific misconfiguration is very useful and very helpful. We have to remember that those development groups that eventually are taking their responsibility are not really experts with infrastructure. They're experts with their own application. This is what they do. So being able to provide them, if they are using an infrastructure as a code, if it's CloudFormation or Terraform, provide them the exact code to fix the misconfiguration is very useful. So these are the four main use cases that we do see out there.
Great. Thank you very much. As promised, we'll now move to the Q&A part of the presentation. And I want to remind you that you can submit your questions using the question pane on your webinar control panel, and you see an example of what this might look like on the right-hand side of the screen. And while we're waiting for the questions to come in, I do want to remind everybody that the handouts, the slides of this presentation are available to you as part of this webinar, and you'll also receive a recording in the next couple of days, so stay tuned for that. Avi, I see that some questions are coming in. Maybe we can get started with the first one? Yes, so let's start with Lisa. Lisa is asking, which CI/CD platforms do you integrate with?
So I think that the most popular CI/CD platform, or more to say automation server, let's say, yeah. So we do see that Jenkins is a leader over there, and we have kind of a basic APIs that give the customer the ability to integrate NXG into as part of the CI/CD pipeline. So once they commit, we are aware to a change in the staging environment, and then the customer can get the risk detected over there, either to waive them or to correct the misconfiguration detected, and then continue with the process and deploy to production. So we have a basic API for that.
Great. Our next question is from Justin. And Justin is asking, what about infrastructure as a code? For example, CloudFormation and Terraform and other automation tools, are they solving the same problem?
Automation is very important, and I mentioned that initially, but automation tools are not solving that problem. They are part of the solution. You need to automate, but you have to remember that even when automating, and specifically using infrastructure as a code, it's very easy to add another line of a few lines into your code and create a mess. So you need to automate, makes it much more easy. It gives you the ability to duplicate staging to production or moving between clouds if you're using Terraform. But still, you need to validate that the code and the infrastructure that you automate does not hide inside a potential risk, either on availability, on compliance, on security. So it's a combination.
Right. Good. Let's move on. We have an interesting question from Janet. A lot of ladies on the call today. That's nice. And Janet is asking, how can we test your solution?
So thank you, Janet, for that question. We do have a starter pack, and this gives our customers the ability to explore NXG. Basically, we are giving our customers the ability to scan an environment which is limited to up to 1,000 nodes, which is either an EC2 or a supported managed service by us, like RDS or DynamoDB. And at the end of that process, we are also providing a detailed report, which we call a health check report, which includes summary and also detail about all risk detected and recommendation how to resolve them. So it's very powerful, and it gives our customer ability to evaluate the product.
Great. I think we're running out of time. We have time for just one more question. Let's take the question from Steve, and I promise that we'll address all the other questions via email, so don't worry about that. But let's take the question from Steve. Steve is asking, can you elaborate regarding how your product works? Do I need to install any agents on my machines and give you admin credentials?
So we already went through the demo, but just a bit more about the architecture and the way that we integrate with the customer. So no, it's an agentless solution. So basically relying on the native APIs provided by AWS or Azure. You just need to define a role. We even provide JSON file required in order to define that role on the customer environment. And then we get a read-only authorization. We start to collect the data. We modularize it in a huge graph database that we're using, in our case, ArongoDB. And then we run on top the analytics. We have hundreds of analytics that are related to availability for outage and data loss prevention. And all risks detected, which are outcome of one of the analytics fails, are presented as a risk. We've seen that. And of course, we are adding to that the recommendation in order to resolve potential misconfiguration, and also will provide later on the code in order to configure it properly. And as you saw, we have our dashboarding, which includes all the information about and scoring about how healthy is the organization up to the region level.
Great. Thank you very much, Avi. And thank you, everybody, for joining us today. We hope to see you in the next webinar. Thank you.
Thank you.